Hello, today we want to look at how to generate matrices of refractions. We are going to look at the basic for refractions. Please remember that some of these matrices, some people can just put them in their head, but for us, we want to understand how do they come about. If you know how to generate them, you don't have to take time to cram them in your head. So you need to understand how these matrices of reflection come about. So we shall start with the first one, the refraction in the x-axis. Usually, we use what we call a unit square. We use what we call a unit square. We use this point here, point A, 0, 1, and point B, 1, 0. Okay? And we try to look at the reflection of these points in the x-axis. So that means in this case, the x-axis now is acting as our mirror line. So we're going to reflect these points in the x-axis. Okay. Usually we start with the point 1, 0. So we start with the point, go to point B, 1, 0, point B, 1, 0. And then we see where will this point be reflected when it is being reflected in the x-axis. Where will it be? You can see this point is exactly on the x-axis. That means this point is going to stay exactly here. So B prime is going to be the same as B. So B prime is going to be 1, 0. Then secondly, we look at the point A, which is 0, 1. Where will 0, 1 be reflected? 0, 1 is going to be reflected. You can see this is the mirror line. 0, 1 is going to be reflected over here, giving us a point of A prime, which is 0, negative 1. That means 0, 1 is reflected point 0, negative 1. So what is our matrix of refraction? So the matrix of refraction in the x-axis is going to be these points here written in vector form. We always start with this point on the x-axis. So its image was 1, 0. So we just write them in vector form, 1, 0. And the next point is 0, 1 is reflected to 0, negative 1. And this is going to be the matrix of refraction in the x-axis. Let us try and see how to get the matrix of refraction in the y-axis. That means now the y-axis is our mirror line. So we can shade it like here. This is the mirror line now. Okay, if this is our mirror, the question is, we look at the same points, these points here. The first point is 1, 0. We always start with 1, 0, the point on the x-axis, and then the other point is 0, 1. So where is 1, 0 going to be reflected? You can see this point here, 1, 0, is going to be reflected in the other side. So it's going to give an image. So this is the image of this point here. Okay, this is the point here, and it's its image over here. And this is the point which is negative 1, 0. That means the image of 1, 0 is negative 1, 0. What about this point here? This point here, 0, 1, is on the mirror line itself, is on the y-axis. That means it's not going to shift anywhere. So it's going to stay as 0, 1. So our matrix of refraction in the y-axis, so the matrix of refraction in the y-axis is going to be the first point we talked about it on the x-axis. Write it in vector form, negative 1, 0. And on the second point on the y-axis, the images, you write them in the vector form, 0, 1. This is the matrix of refraction in the y-axis. Let us look at a reflection in the line y equals to x. How do you get this matrix? It's going to be the same process. We look at 2 points, C, 1, 0. Let me call this one A, and I call this one B. It doesn't matter. You can call it NNM. So we are looking at a point A, which is 1, 0, being reflected into the line y is equal to x. So you can see this is the mirror line now. Okay. So when you reflect it, so A is going to go exactly where B is. So we are going to have A here, going from here to be reflected to that point. It to go there when you reflect it. So that means A is going to be reflected to 0, 1. And then that means the image is going to be exactly there, which is exactly the same as that. And then when you have B, the point B, which is 0, 1, from the same thing, B is also going to be reflected exactly back to in the position of what? Of A, like that. That means B is going to be also, B is going to be A, which is 1, 0. So that means the matrix of refraction, we said we write these images in vector form. So we have 0, 1, the first one, and 1, 0. So this is the matrix of reflection. Matrix of reflection in the line y equals to x, like that. Let us generate our last matrix, the matrix of reflection in the line y equals to x. As we said, we consider the 2 points 1, 0 and 0, 1. So we are calling this one A, okay, and we are calling this one B. Okay, now we are reflecting the A into the line, this is the line y equals to negative x. So we can have this our mirror now. Okay. Now you can see from the laws of reflection, you can see that this point here, 1, 0, is going to be reflected onto that point over there. Onto that point. And that point is going to be a point which is negative. It's going to be 0, negative 1. So that means 1, 0 is going to go to a point which is 0, negative 1. Okay. And the point B, which is 0, 0, 1, is the point over here. Is the point 0, 1 is going to be reflected to which side is going to come onto this side here. Okay, come here, which is going to be a point which is negative 1, 0. That means B is reflected point negative 1, 0. And writing these images in vector form, you have 0, negative 1, and then negative 1, 0. This is the matrix of refraction in the line y equals to negative x. That's how we find matrices of reflection. Thank you for watching this video. Please don't forget to subscribe, turn on the notification, share, comment, and like. Please let me know what you want to study in the next lesson. Thank you.